So moving over into taking our impedance model and its modifications to the design line widths over into the CAM aspect and modifying the customer's uh, data, the to reach those nominal values, the process is straightforward enough to where we take the design line width of whatever the customer provided. In this example, the 18.8 design line width, we bumped it up or bumped it down to a 17.3, and then apply an edge compensation on that, which brings it back up to an 18.3. Um, this right here is the impedance line specified from the customer's data, and it was has been modified to be the nominal line width. And as you can see, there's no solder mask on top of it, so it matches the same design where no solder mask is applied. So the design line width of the impedance trace matches exactly what the modeled simulation of the impedance line brought forward. The So after modifications to that is made, um, coupons that represent the impedance line are made as well and have the exact same characteristics as the impedance lines. And what happens with these coupons is they get placed on the exact same panel that the boards are built on. And when the boards are built, the impedance coupons have a direct representation of the impedance coupons designed on the printed circuit boards. Those impedance coupons are used for testing and validation. After the boards are built completely and routed out and ready to ship, the impedance coupons are cut out of the board and tested on a TDR machine, a time domain reflectometer that probes the ends of the impedance trace and measures the impedance and ohm values across the line, and it validates the impedance line is within the nominal or required tolerances as specified by you, the engineer.